we're going to look at transformations. I started my video? Yes, I did. Okay. So transformations again are ways of determining more complicated functions from the basic functions we discussed. So they are shifts, horizontal, vertical, reflection, and the last one, stretching or shrinking. Okay, shift. I'm shifting. Or I'm shifting. Reflection. I'm reflecting. Reflecting. So, or reflecting. Stretching. I'm stretching or I'm shrinking. Or I'm stretching or I'm shrinking. So, of course, here, vertical, horizontal. Okay, let's start slowly. We start with shifts. And we're going to start with a vertical shift. So what is a vertical shift? Here's my graph. I want to shift it up or I want to shift it down. So here's our first example. Let's say from these 6 functions, I am choosing the absolute value of x to create a more complicated function. F of x equals the absolute value of x plus 3. Or another one, let me use let's use g so it's not confused with the first one. G of x equals the absolute value of x minus 5. Notice that the change, so the base function, is the absolute value of x. I chose the absolute value of x. We can choose any other from those 6. I said, okay, I'm going to start with the absolute value of x because I like the absolute value of x. It's like a v function. So this is the y value. You know f of x is the same with y. So what changes here? See, the y value doesn't change. I mean, the x inside does not change, but the y value is plus 3. So the y value adding 3, or the y value subtracting 5. So what changes again? This is a change in y value. See, x is the same. There is no change in x. But the change is in the outside, in the outcome. The initial absolute value is this graph. This is the base function, absolute value of x. Here it is. A v function bisecting the first and the second quadrants. So this is y equals the absolute value of x. In order to graph the absolute value of x plus 3, I have to shift this graph up 3 units. 1, 2, 3. And the graph has to be parallel. Don't change the shape. So this is up 3 units. And this is the graph, the absolute value of x plus 3. Now, how do I graph this? The original or the base function or the simplest function down 5. From the simple function down 5. 1, 2, 3, 4, 5. And has to be parallel to this. Of course, my graph cannot be perfect. So this is y equals the absolute value of x minus 5. So this is how we illustrate vertical shifts. The base function doesn't change, but the actual final value changes by moving it up 3 or moving it down 5. So let's choose another function so to illustrate vertical shifts. So can anyone choose another function? Linear, quadratic, we already did this. Square root, cubic function, cube root. Which of these functions would you like to illustrate vertical shifts with?
Square root.
Square root, perfect. Okay. If you have an example, or if not, I will create one. So with f of x equals the square root of x, how will you create a shift up of 2? Shift up 2. And f of x down 3. What do you think?
Would it be square root of x plus 2?
Yes, exactly. Nothing changes here. It's a change in the y value. And what about down 3? Anyone, please?
Square root x minus 3.
That's it. Outside. What I mean is, you said it correctly, but what I mean to say is not this. This is a different type. The square root does not change, and we're subtracting 3 from the y value. I can never open that one for some reason. I don't know. So I don't want to confuse you now. I just want to delete this. Okay. Good. So first we are going to graph the square root of x. And we know the domain again of the square root of x. Please, can anyone tell us the domain of the square root of x, please? Please.
0, infinity.
Thank you very much. So here's the graph. This is the square root of x. We want to shift this graph up 2 units. No change in shape at all. So this is the square root of x plus 2. And now I want to graph the square root of x minus 3. 1, 2, 3. The square root of x minus 3. Do we understand the vertical shift? We're going to have many examples, but do we understand the idea of the vertical shift?
Yes.
Okay, moving on. Horizontal shift. Horizontal shift changes x. So remember here what happened. This was the y value. It changes by up 2. This were the function, this is the function, the original or basic function, and the y value changes. No x value changes. Now horizontal shift is something like this or this. So if this is the base function, x changes now. Y does not. Everything happens at the same level. Here it did not happen at the same level. The y changed there. But now for the horizontal shift, or from the original, no change in y, left or right. So let's illustrate. Please choose a function to illustrate horizontal shift. Any function you want. We can choose the same. We can choose quadratic. We can choose cubic to illustrate. For which one?
Cube root.
With the cube root. Perfect. The cube root is, it is. Okay. So we have the function, the base function, the cube root of x. Perfect. Notice now that x changes. So f of x equals the cube root of x plus 3. And the other one, f of x, the cube root of x minus 2, as an example, or examples. It's not outside of the function. It's inside the function. I'm changing x to x plus 3. I'm changing x to x minus 2. That happens. When that happens, I either move to the right 3, or to the left 2, or to the right 2, or to the left 3. And I'll explain which one it is. Okay? So you don't have to memorize this. I just want you to understand it. So we graph the cube root of x. Here's the cube root of x. Y equals the cube root of x. Now, one of them adds 3. The other one subtracts 2. We are interested in finding the x-intercept. Where will the x-intercept for this be? In other words, no, because 3 plus 3 is not 0. I know it's a little bit tricky. So which number plus 3 is 0?
-3.
Yes. So I know it's kind of against what you expected, but the x plus 3 moves the graph to the left because the x-intercept is here now. So this graph, when we change x to x plus 3, or any plus, whatever you want, it will shift the graph to the left. Where is the x-intercept for this one? When x...
No.
Yes, that's why this one will be a shift to the right of 2. So let's graph this one first. So this graph is the cube root of x plus 3, because again, we are looking for the x-intercept. Here at 3, 3 plus 3 is not 0. So the x-intercept for this is right here at -3, 0. -3 plus 3 is 0. The cube root of 0 is 0. The other one, as you told me already, it has the x-intercept at 2. So here it is. It shifts this graph to the right 2 units. I know this is not what you have expected, but please understand the concept. I'm adding to x, left shift. I'm subtracting from x, right shift. because that's where the x-intercept is now, 2 minus 2. Negative 3 plus 3. Okay, let's illustrate with one more function. Horizontal shifts. And then we'll try a combination of both. Let's do x squared this time. So we have f of x equals x squared. Can anyone give us two possibilities? One left shift and one right shift. Just create whatever you want. But remember, you have to change x. Don't say plus outside or minus outside, because that's a vertical shift. Can anyone give us two examples? A left shift and a right shift? Please. Anyone, please? Okay, I'll do one. Can you do the other?
X plus 4 squared.
Good. Does this one go to the left or to the right?
To the right.
Yes, right 3. Where does this one go?
Left 4.
Left 4. Excellent. So let's graph. We're going to graph x squared first. Very simple. Nice graph. You already told me that the first one moves the graph 3 units to the right. And you already told me that the other one moves the graph 4 units to the left. Perfect. Now here's what I have for you. If you follow and pay attention to what I'm doing here, you'll picture this graph in your mind immediately. So in order of operations, very important, we present the transformations in order of operations. Transformations in order of operations. Always. First, this is what I have to perform first, and then take the square root. So if I ask you, find the value of this function evaluated at x equals 7, what will you do first? Minus 3? No. You're going to put 7 in here, you're going to get 9, and you're going to take the square root and then subtract. So in order of operations, this is first, then second. So we have to list them in the correct order. So the correct order here is order of operations, the following. Number 1, I list the base function or the basic function. Then I say number 2 is this, the square root of x plus 2. What transformation is this? Is it a vertical shift? Is it a horizontal shift? And which direction? Vertical, horizontal, and which? Careful, we're not adding outside. We are changing x. We're changing x to x plus 2.
Horizontal.
Yes. Which direction?
Left.
Left 2. Awesome. And final transformation here is the square root of x plus 2 minus 3. This transformation is on this function. This transformation is on this function. So now from this function, I'm subtracting 3. What type of transformation is this?
Down 3.
Down 3, very good. Of this one. Yes, thank you. Down 3. So now can you picture the graph? The square root of x, move to the left 2, and down 3. This is the idea of transformations. Being able to picture the graph, not an exact graph. I'm not interested in an exact graph. I'm interested to picture the graph quickly in my mind. So here is the square root of x. Then you told me to shift it left 2. Okay, fine. I will shift it left 2. And then you told me shift this orange graph down 3. And that's exactly what I'm going to do. Of course, this is not an accurate graph. But this is a shape that I got quickly, and I know what to expect. So this is the final graph, which is f of x, the square root of x plus 2 minus 3. I graphed the original, or the base function. I shifted it 2 units to the left, and then I shifted this down 3. This transformation is on this. This transformation is on this. So what did we do? From a very simple function, we used 2 different transformations to create a more complicated function. Okay,